Yes.
Okay. Yeah.
So when our Y is discrete in nature, we went for attribute agreement analysis because the data is discrete in nature, which is either binary, maybe could have more than two also, but yes, no, pass, fail sort of a data that I had, which is an attribute data. In that case, I went for a attribute agreement analysis, which we did in on Minitab as well. But in case when my Y is continuous, okay, then in that case, I do a measurement system analysis tool, which is called Gauge RNR, and RNR stands for repeatability and reproducibility. So I am assuming that my data is continuous, and which is in probably minutes or seconds, which can have a lot of variance, like 50.9, 50.7, like where there is no true false, wherein if I give an opportunity to a different operator, he will come up in fractions, he will come up in 2 decimals, 3 decimals, etc., etc. So I want to do the MSA for continuous data. The name of the technique is called Gauge RNR. Okay, so I just want to reiterate the golden rules of Gauge RNR. First, the number of distinct categories should be equal to or more than 4. Distinct categories means that my equipment, my measurement system variation should be able to measure in different categories. Okay, I should be able to measure that data in a different sort of categories. So 4 is a threshold. If it is 4 or greater than 4, it means it's a good measurement system. I would pass it. Second, percentage contribution of Gauge RNR should be less than part to part variance. So when I'm saying part to part, which means transaction by transaction. So which means the total variation of the data that we have should be lesser than part to part. Okay, that's the second golden rule. The third golden rule is the percentage tolerance. Okay, if it is lesser than 10, it is good. If it's between 10 to 30, we accept, but with caution, because there are some places where we don't accept 10 to 30. And if it is more than 30%, we reject. To pass the measurement system for Gauge RNR, all these 3 golden rules needs to be met. If there is if there is one of the rules which is not met, I would not accept the measurement system analysis. I would say that this measurement system is okay. This is number of distinct categories. This is something which my measurement system is able to measure the data in more than 4 different ways. Okay, that is a number of distinct categories. Okay, that's what it tells about. The higher the distinct categories are, the strongest my measurement system is. The lesser the distinct categories is, the weak my MSA is. So that's what it does. So let's do a practical in Minitab. It shows it.
One question: does it mean the distinct categories mean if I am measuring a part, does it mean that I have to take dimensions for the length, width, and the thickness?
No. There is one thing which I'm measuring. So let's say I'm doing a project on improving the maybe reducing the width of a given product. Okay, so which means that there is a complaint received from the customer that there is an extra width which is resulted into a lot of cost of poor quality, customer satisfaction, and business. Now I'm doing a project on reducing the length, okay, or maybe reducing the variation in the length. Now I only have one CTQ, which is reducing the length. I will not take the other metric into consideration. Distinct category here means that my equipment, my measurement system, my equipment should be able to measure in different categories, which means into different ways. That is what distinct category is. Okay, so this is something which I don't calculate. This is something which is being calculated by Minitab itself, wherein the more the distinct category is, which means I would be able to measure this data in 4 different ways, 5 different ways, 7 different ways, which means this data this measurement system is more robust than the other measurement system. Okay, wherein I will be able to do the measurement system analysis in 4 different ways, not using the 4 different CTQs, using the similar CTQs in different permutation and combinations, which I don't know the calculation how it is to be done, because there is a standard which is built in. The calculations are done on the back end, but yes, if the measurement system can be categorized more than 4 distinct categories, it's a good measurement system. So let's do this exercise on Minitab and see what does my gauge RNR tells me. Okay.
But in
So I have
manufacturing, we are doing this. In manufacturing, three types of data, the same data and with 3 appraisals with 10 times. That is how I have seen in my company.
So please repeat, Vasu. How many parts that you look into consideration? 3 parts and 10 operators.
No. 3 appraisers.
3 appraisers. Okay, 3 operators.
Three appraisers and 10 values.
10
3
values. So 3 trials,
yes.
3 appraisers, and how many parts that you measure? 10 parts. Okay, yeah. Because then in that case, you want to do it again and again. Okay, good. So I have an example here. Okay, wherein I have 2 different parts and I have 3 different operators, Simar, Rohit, and Abhishek, and I have the measurement here. Okay, and I want to do a gauge RNR. So here you notice it's a continuous data. That's why it is not showing pass or fail. It is showing the real values. Okay, let's say this measurement is in kgs. Now I want to do a gauge RNR to check whether my gauge RNR pass or fail. So I go to Minitab. I put this here. Okay. So I go to stats. I think this is under quality tools. Yes. So stats, quality tools, gauge study. Okay. We go for gauge study crossed. So in part, you will mention the parts. In part, you will mention the part. In operator, you will mention the operators. And the measurement data, you mention the measurement that you've taken. Okay. And then in options, you give any tolerance that you want to give. So I've given a tolerance of 12 here. Okay. Tolerance, so this is the upper specification, lower specification. And I click on OK. I click on OK here. Here comes my gauge RNR. Let's look at the graph first. Okay. Can you all see the graph?
Yeah.
Okay. What was my first golden rule? The first golden rule is number of distinct categories should be greater than or equal to 4. So that's not there in the graph. So let me just close it. Let me show you the number of distinct categories. Here the number of distinct categories is 1, which means there is only one category wherein I would be able to measure this data. So my gauge RNR is failed in the first condition itself, but I'll still go ahead because this is the data that we have. Second condition, it says gauge RNR as a percentage of contribution should be less than part-to-part variance, which means my part-to-part variance should be higher than the total gauge RNR. Okay, so that's something which I can show you with the help of the graph. Here you see, this is the part-to-part. This is the blue is the contribution variance. Okay. If you hover over it, you would see it's 58. Okay. And the contribution is 76% out of the total 100%. And the total gauge RNR contribution is 41. And the variance is 64. So which one of the higher? Is part-to-part higher or is total gauge RNR higher?
Part-to-part is higher.
Part-to-part is higher, which means that it is acceptable. It is still acceptable. Okay. Now I want to show you something else as well. You see here, there are 3 different operators and different parts as well. And wherein you want to make a call that which operator is not doing really well. and I want to ask this question from you. Let's look at this graph. So this is a graph by operator. This is a graph by part, and this is part operator both interactions. Okay, this would help us to analyze that who is making errors. So you see here that Abhishek, Rohit, and Simar. So for part 1, the mean that I have come is 10.5. Here it is 10, and here's 10.5. Okay, Abhishek 11.5, 11, and 11. Okay, here if I look at the measurement by part,
There is a difference.
More different.
yeah, there's a difference.
Checking.
There is a measurement difference between the operators and even on the path.
Absolutely.
Yeah.
But how do I make a call that which operator? Because my second category is pass, but my number of distinct categories is not pass, which means this measurement system is not good to go. We will look at the third condition in a while, but just want you to interpret this graph. And I will explain it as well. Post that. Want to know from you.
So
What does this say?
yeah, so when we look at the X-bar chart, we look at the slope that is being formed by for each of the people. So here you can see that Simar has got the lowest slope of line or most flat line. So
Yeah.
that means that the Simar's data is much better than Rohit and Abhishek. And both of them, they are pretty, one of the extreme values is pretty close to the upper limit or the lower limit.
So let's not get into the lower limit or because that is something which we'll be doing in the control chart. So I haven't covered that part yet. Let's not talk about UCL and LCL right now.
We
That is
have
something which
actually, we have in the process capability.
No,
part.
sorry.
Variation
That
and
was
checking.
USL and LSL.
Yeah.
That was upper specification and lower. This is UCL. This is control limit.
Okay.
I haven't covered the control limit yet. So don't worry about it. Don't worry about it. So we will discuss the control limit in the control phase. So don't look at these numbers here. Just look at the graphs. So your answer is absolutely correct. Your answer is absolutely correct. If I look at the spread here, okay, I see that this operator is performing better than these two operators, okay, because his measurement and his part 1 and part 2 variation measurements
Stable.
are stable. However, if I look at these two operators, their part to part measurements are not stable. Let me show you something in the interpretation as well. Okay. So this is how it started.